Let's see. So we wanted to graph the function, and what we did, there's more to this process than I usually do, but since it's a quadratic, basically we can plot the vertex, show the axis of symmetry, and then just choose points equidistant from the axis of symmetry on either side of the axis of symmetry. So our vertex is negative b over 2a. Now we could have gone straight to the vertex, but we decided to do completing the square to show a demo on completing the square. So we put it in standard form, and then one more step to put it in standard form. We would have to distribute the 3. Yeah, so we have the arrow. That's our standard form. Or actually, that's not correct. Alright, I found the mistake. Yeah, we need to fix that. Okay, so instead of that line, because I realized that I canceled the 3, we want to build on this line. So we would need to distribute the 3, and then this will give us a result of 3x minus 1 quantity squared minus 4. Okay, so then if we had that, that's what we want actually. So then that means our vertex, our h comma k, will be 1 comma negative 4. Yeah, that looks a lot better. Oops, yeah. So we actually need to go back and clean this up. So yeah, I think our x-intercepts are actually okay though, because so the line was fine. We just chose the wrong line to graph from. So the f of x is going to be this line here in blue, 3 times x minus 1 squared minus 4. We distribute the 3 with there. So if we finish doing the completing the square on the left that we have in black, we use that to solve for x, and that'll give us our x-intercepts as 1 plus or minus 2 by root 3. So then I think we need to make a change to our graph. If we go right 1 and down 4, yeah, I thought it looked different. Okay, so let's clean up. Let's see. So we go, this is wrong. So we go right 1 and then down 4. And then it opens upward. Alright, so let's, okay, so we'll do this. Alright, then we'll go 1, 2, 3, 4, we'll do 5, 1, 2, 1, 2, 3, 4. This is the positive x, this is the positive y. So then the vertex should be right 1 and down 4. So right 1, 1, 2, 3, and here's the vertex. So we'll do that in blue, I guess. And then we have our axis of symmetry. So the points on the parabola should be equidistant from here. So then if we choose a point on the right, for instance, so this is when x is 1. So if we move, it would be easier to move 1 to the left actually. So when x is 0, if we go back to our original, then y is negative 1. So since we have this point on the left, then we also have a point on the right that's the same distance from the axis of symmetry. Let's do when x is negative 1. So if we go back to our original, when x is negative 1, that'll be 3 plus 6 is 9 minus 1 should be 8. So I think 8 goes off of our chart. So then if we connect what we have with a smooth curve, we just need to go off the chart before we reach 3. Go off the chart before we reach negative And this actually looks more like what we graphed, because I remember I noticed that when we graphed it, it looked a little different. So let's take a look at it. Okay, I gotta refresh. That's better. Okay. So then let's look at the graph again. So the original. So we have 3x squared minus 6x minus 1 graph. Now, I didn't happen to do the same window, but we have a similar graph. Okay, so yeah, that's why we always want to check before we go forward to catch things like that. Did I just use the wrong? No. And then let's just plot these points and make sure that they're on our graph as well. So we're going to go to Stat, Edit, and then we're just going to put in the vertex and this the x-intercepts. And we can also plot the points that we have. So let's put all of these points on there. So the far left should be the left x-intercept, so that's going to be 1 minus 2 divided by the square root of 3. And then that y value is going to be 0. Then the next one, x is 0 and y is negative 1. Then next is the vertex, which we said was 1 and negative 4. And then right, we had 2 and negative 1, 2, negative 1. And then the right x-intercept should be 1 plus 2 divided by the square root of 3. And the y should be 0. So let's plot these. So we need to go to Stat Plot and turn it on. And then let's get a similar window to what we have. So if we go to the window, our x-min, we can go down to maybe, go to negative 1. We'll go to negative 2. The max, let's see, 1, 2, 3. Let's go to 4. We can go in steps of 1. The y-min, 1, 2, 3, 4. We'll go down to 5. And up to 1, 2. We'll go up to 2. And then steps of 1. Now we should have our plots pointed. And it goes through all the points. Okay, so now I feel better about this. Yeah, actually before I was doing that in the night and I was like half awake. So I was like, let me stop and finish this in the morning. So now it's morning time. And it feels a lot better. So, right. Okay. So let's see. It says graph the function and then solve the inequality. So we solved it. We basically solved for the 0. So what x has made it 0 is the 1 plus or minus 2 over root 3. And then the question asks, when is our graph less than 0? So it's actually less than 0, or in other words, below the x-axis between those intercepts. So the solution would be this. And then, so those are those. And we have the graph. And that's about the best that we could do right now.